Good afternoon, guys. Hope you're having a great day. This is going to be day 2 of our transformation graphing notes with our logs and exponentials. So yesterday, let's do a quick review. We talked about exponentials. So we talked about this part right here. Okay? So we talked about this part right here. And we learned that exponential functions have a horizontal asymptote. The parent function is always at y equals 0, but adding k to a function can cause the horizontal asymptote to shift up and down. An exponential graph always crosses a point 1 comma b. b is the number attached to the exponent. And at the parent function, it always crosses at 0, 1. Now again, that can shift left and right depending on what h is. And then right here is the vertex form of exponentials. Y equals ab to the x minus h. H is always the opposite of what we see, plus k. Our domain for an exponential is always negative infinity to positive infinity, always all reals for the domain. And our range is going to be where our horizontal asymptote is to positive infinity, or if the graph's reflected, from negative infinity to our horizontal asymptote, just kind of depending on what the graph is. So that was our review from yesterday. Today what I told you we're going to do is we're going to talk about logarithms. So the second part of our homework, I think there's 4 problems on your notes about logarithms on your homework. So the vertex form of logarithms would be right here. It would be y equals a. A again is doing the vertical and horizontal stretch and shrink. Log base b of x minus h. H again causes the graph to go left and right. H is always the opposite of what you see. And then plus k. K is outside the parentheses. K causes the graph to go up and down. So when you're looking at a log equation, and if you don't see parentheses, let's say that you see log base 3 of x plus 4. That right there is going to be my k. For the same instance, let's say I just add parentheses to that, and that changes it a little bit. Let's say I have log base 3 of x plus 4. That then is going to be my h. So just pay attention. Is it inside the parentheses with x? Then it's h. Is there no parentheses? Then it's going to be k. That's how we distinguish if it's h or k with logarithms, because sometimes they seem like they're the same thing. Okay? The only other thing we need to remember with logarithms is logarithms have a vertical asymptote. The vertical asymptote is at x equals 0 for the parent function. Okay? That can change left and right depending on h. Okay? And the parent function also crosses 1 comma 0. Exponentials and logarithms are inverses of each other. So an exponential is horizontal at 0. A log is vertical at 0. The exponential is at point 0 comma 1. Logarithm at 1 comma 0. The same thing is true. Remember, they're inverses. So when you're talking about domain and range, they're also going to be inverses of each other. So my domain for exponentials was negative infinity to positive infinity. So my range for logarithms is going to be negative infinity to positive infinity. Okay? Because you're just going to flip. And then my range for exponentials was my horizontal asymptote to positive infinity. So that's now going to be my domain is going to be my vertical asymptote to positive infinity. Or if the graph is reflected, it could be from negative infinity to my vertical asymptote. But again, logarithms and exponentials are inverses of each other. So all you do with inverses is you flip-flop your x or y. Okay? So let's look at the next couple graphs here. So yesterday we talked about 6, 3, and 1 being exponential functions. And we didn't talk about 2, 4, or 5. Well, if you look at 2, 4, and 5 on this box right here, you can see that they all have vertical asymptotes. So that's a sign to us right away. They have vertical asymptotes, so they must be a log equation. They are not an exponential equation. Okay? So let's look at this first equation right here, D. So it says the natural log of x plus 2. Well, that plus 2 is inside the parentheses, so that's my h. So that is causing the graph to shift left 2, which would cause the horizontal asymptote to shift left 2. So if we look at number 5, our vertical asymptote's at negative 2, which is exactly what it would need to be. So D must be 5. Okay? And then E, if we look at that, it says g of x equals 2 plus natural log of x. Well, I'll be completely honest with you. I probably would not write it like that. If I was going to write it, I would probably write it like this. However, people would get confused because they might think the 2 is inside the parentheses. But either way works just fine. But now we're going to try to see that. So the plus 2 just causes the graph to shift up 2. Okay? So right now it's between 2 and 4. But it doesn't do anything with the vertical asymptote. And we know for the most part, unless something is reflected, our graph is going from 0 to positive infinity. So E must be 4. And then our last one is g of x equals 2 plus natural log of negative x. Well, a negative number inside the parentheses causes the graph to shift across the y-axis. We'll talk about more of that detail. My vertical asymptote's still at 0 because there's no h there. My k is just causing, again, the graph to shift up. And if you look at number 2, you can tell that graph's up a little bit. So f would be 2. Okay? So in the first part of your homework when you're graphing logarithms, just make a t-chart, plug them in, and get a good idea. Make sure you identify your vertical asymptote, just like you did on exponentials when you had to identify your horizontal asymptote. Okay? So we're just going to scroll down here and go to our logarithm page right here. So here's the notes that I would look at for logarithms when we're talking about transformations. They're the exact same thing for exponentials. H causes the graph to go left and right. Remember, H is opposite of what you see. K causes the graph to go up and down. Okay? H, when you're going left and right, is also going to affect your vertical asymptote. So just know here, H affects vertical asymptote. Okay? It causes it to go left and right. Reflection, the number inside with the log is over the y. The number inside in front of the log is going to go over x. And we're not going to worry too much about horizontal and vertical stretch. I actually took those off the worksheet because that's not really the priority. If we can get a basic understanding of logs and exponentials, we're good because you'll go over this again in pre-calc and in college algebra. So let's do a couple of these problems together and see where we're at. So on this example right here, we have described the transformation. And this is what you do on the first part when you're graphing them and then describing it. And it can be very shorthand. So I have f of x equals log of x. So if I look at A right here, that blue line is my f of x, okay? You'll notice that 1's on the graph, okay? We're going from there. And they're saying, okay, now let's put g of x. And it's a negative 1/2 x, okay? The negative is going to actually reflect it across the x-axis because that number's inside. So for this one, we would reflect across the y-axis, okay? So we write that down. And then again, we're not going to too much with the scale factor there, but it also causes it to be a horizontal stretch. So it's stretching it out longer. Again, on the worksheet, we're just going to talk about reflection, H, and K. Okay, now let's talk about B. So B, and again, our asymptote, let's go back to A really quick, would be right at x equals 0. That would be our vertical asymptote. And we didn't do anything with our H, so our vertical asymptote would stay the same for both. So now for B, we have log base 1/2 of x, and that's our f of x equation. And that's the blue one on B right here. And then we have g of x equals 2 log base 1/2 of x plus 4. So if I'm looking at this one, I know that A is 2, and I know that H is negative 4, and I know K is 0. So my graph is just going to shift left 4. So if I look at the point here, when I'm looking at it, on the f of x equation, that point right there is at 1, 0, which we know that's true because it's the opposite of exponential. And I just go over 1, 2, 3, 4. So I just slide the graph over 4, and then I can make a t-chart and find some other points from there. On the blue function, my asymptote was right here, but because I'm shifting the graph over 4, I move it over, and it's now going to be over there. 1, 2, 3, 4. So our vertical asymptote on our new graph would be x equals negative 4. Okay? And then again, this graph actually is stretched vertically by a scale factor of 2. Don't worry too much about that. All I would really want you to say here is left 4. And that would be an okay answer for right now. Okay. Let's finish up a couple more problems and then we'll go from there in the notes. 5 and 6 are like the first part of your worksheet. You're graphing the two graphs and then you're telling me the transformation. Again, keeping it very shorthand is fine with me. And then, again, if you're struggling a little bit, you could try this example here and this example here. It kind of writes through exactly what you're doing and how you find those points. And let's finish this up with some problems that you're going to see the last 4, I believe it is, on your worksheet. It says, okay, here's an equation. Do these things to it to make it change, okay? And what I'm going to do here, because I took these out of your notes, is I'm going to get rid of where it says to be a horizontal stretch of a scale factor. Now, the answer they have listed there is with that. We're not going to worry about that too much. So it says on 7, let g of x, this is a little review from yesterday, let g of x be followed by a translation up to of the graph f of x equals e to the negative x. So if I was going to look at that, I want to go up to. Well, I know that going up involves k, okay? So I know that going up involves k. So I'm going to go g of x equals e to the negative x. Nothing is changing there, but I want it to go up 2. So at the very end, I'm going to add 2. The 2 is not in the exponent. The 2 is up. It's even with the e. So make sure it's not up there with that x. If it's up there with the x, it's h. And that would be my answer. G of x equals e to the negative x plus 2. Okay. So now let's look at 8. 8 says let g be a reflection in the y-axis. So a y-axis, the x inside the parentheses is going to be negative, followed by a translation of 4 to the left. So we're saying 4 to the left, we're doing opposite, okay? So, but the negative inside is going to throw it off. So actually, let's get rid of this reflection across the y-axis, and let's just do a translation of 4. Things get a little more complicated there, okay? We're going to keep it pretty basic here. So let's say I have f of x equals log, and we know if there's no base there, it's log base 10. Translation of 4 to the left. So h is on the inside, so it's x. Left is negative, but it's the opposite of what I see. So this would be my answer. Okay? So if you have any further questions, make sure you get on Zoom, but you should be able to complete those 10 problems on the worksheet, graphing the exponentials, graphing